of videos on digital media infrastructures, Sai focused primarily on hardware. However, digital media infrastructures also include software. The rest of this week's videos will focus on these software infrastructures. In this video in particular, I'll provide a rough working definition of 3 key terms that will be important in helping you understand software infrastructures. These 3 terms are algorithms, automation, and artificial intelligence. Let's start with algorithms. While algorithmus was essentially a procedure for calculating Hindu-Arabic numerals, today algorithms are most fully associated with computer science. In this context, algorithms are, as digital media theorist Tarleton Gillespie puts it, a set of encoded procedures by which a computer can transform input data into a desired output. As this suggests, algorithms and databases are inseparable. Algorithms are a particular collection of rules that computers apply to data to deliver up specified results. The algorithms that power the ubiquitous search engine Google provide an excellent example of this. When you type, say, shoe stores in Wellington, how does Google decide which results to show you, and in what order? The answer? Algorithms. Google has a number of very powerful algorithms or recipes for processing the raw ingredients of its databases and turning them into search results. However, the most famous of these is PageRank, an algorithm named after the founder of Google, Larry Page. PageRank works by counting the number of links to a page to gauge how important the website is, on the assumption that the more important a website, the more links from other websites it's likely to receive. In Google's case, of course, this search algorithm will be interacting with other algorithms. Algorithms designed, say, to block websites containing material banned in the searcher's country, or to rank websites according to a search term's appearance in the page's title, header tags, and meta description. While Google Search, however, provides an excellent example of algorithm at work, algorithms are everywhere in our culture. As cultural critic Ed Finn has put it, we entrust these little pieces of quotidian technical magic with booking vacations, with suggesting mates, with evaluating standardized test essays, and performing many other kinds of cultural work. And as we'll see in later videos for this week, algorithms are far from neutral or innocent parties in the search for information. We now turn to our next term, automation, a phenomenon of which algorithms are but an example. Automation is the use of technical systems to perform a procedure or process with minimal or reduced human intervention, usually with the aim of saving money on resources and labor, and sometimes, although certainly not always, in improving quality, accuracy, and precision. Automation can be as simple as a household thermostat controlling a boiler, so that we don't have to constantly adjust the boiler ourselves, or as complex as the search algorithms that deliver up search results on Google so that we don't have to manually search through every single web page. Yet as digital media critics Nick Cernak and Alex Williams note in their book Inventing the Future, the logic of automation is deeply ambiguous. The first issue revolves around the effects of automation on our labor cultures and economies. On the one hand, automation has always held out the utopian promise of increasing productivity and liberating humanity from the drudgery of work. And I think we're all pretty pleased that we can entrust, say, our laundry to a washing machine rather than having to do it ourselves, or that most operations on aircraft are being performed by a computer rather than a human being. But the flip side of being liberated from work is having one's job stolen by machines, as people back in the 18th century protesting the rise of the factory machinery that threatened to displace traditional textile work well knew. Today, many economists contend that automation, for example, the self-checkout machines that have to a large extent replaced checkout operators, is one of the central reasons why over recent decades we've seen the stagnation of wages, the breakdown of stable, secure jobs, and the emergence of surplus and permanently unemployed populations. While the disappearance of some more manual work has been offset by the emergence of new forms of work that are orientated around, say, information management, Cernick and Williams contend that anything from 47 to 80% of current jobs are likely to be automatable in the next 2 decades. The second issue with automation is to do with the nature of recent developments in automation, where we have seen a shift from mechanical systems that are about automating human movement to digital systems that are about automating what were traditionally human decision-making processes through digital technology, data, and AI. For example, today in Australia, automation is widely deployed in the social services sector, with major programs in government departments such as Social Security and Health reconfiguring social and support via automation. While these new systems and digitally supported economies of care have brought many benefits to users' lives, there are also challenges in that machines, even so-called intelligent machines, can be remarkably stupid when it comes to the complexities of human experience, and thus aren't always able to make decisions about people's welfare that take account of nuance, or that respond readily to novel and unique situations. A third issue has to do with what's known as automation bias, a phenomenon that's been observed in every domain from spell-checking software to autopilot. Automation bias is observed when we value automated information more highly than the evidence supplied by our own senses. And as you can imagine, this bias has led to disaster, as in what has become known as death by GPS, a term that's evolved to describe cases where travellers, unfamiliar with an area, privilege the GPS instructions over their own experience to disastrous effects. James Bridle relates one example of a group of tourists in Australia driving their car down into a beach in the sea because their satellite navigation system assured them there was a viable road in front of them. While helping us in many respects, then, automation brings with it a host of problems of its own. While automation and algorithms can be defined technically, artificial intelligence, the third term we'll be dealing with today, is a little bit more complicated. The first reason for this is that artificial intelligence names not so much a particular kind of technology, but a broad field of study at the intersection of computer science, psychology, robotics, mathematics, and other fields. The second reason is that the technologies at the heart of this field of study are in a constant state of evolution. There's no historically stable and universally accepted definition of intelligence, and thus no historically stable and universally accepted definition of what a machine must be capable of before we deem it an intelligent machine, or AI. As a result of this, over time, our understanding of exactly what constitutes AI has shifted. In the 1950s, for example, pioneering English computer scientist Alan Turing decided that the measure of an intelligent machine was whether a computer could imitate human behavior and thought convincingly. However, this seemed to rely on a very limited definition of intelligence, i.e. as the capacity to display human language competency. More recently then, the term AI has come to be attached to emerging machine learning technologies that are able not just to display existing competencies, but actually to learn, that is, to acquire information without being explicitly programmed on the basis of large quantities of input data. Machine learning technology then basically involves a set of algorithms that parse data, learn from that data, and then apply what they've learned to make informed decisions. A ready example of a machine learning algorithm is an on-demand music streaming service that works to automate our music recommendations. For the service to make a decision about which new songs or artists to recommend to a listener, machine learning algorithms in platforms like Spotify associate the listener's preferences with other listeners who have similar musical taste. Linking back to the discussion of automation above, machine learning today is applied to automate all kinds of tasks and services across multiple industries, from speech recognition software and translation services to the work of data security firms hunting down malware, or finance professionals looking out for favorable trades. This video has discussed 3 terms key to our understanding of the basic software that underpins our lives in advanced Western countries today: algorithms, automation, and artificial intelligence. In the next video, Kevin will drill down into algorithms in greater detail in order to underscore their implication in existing political and social inequalities.